Good morning, everyone. Thank you for joining us on this discussion today. If anyone hasn't gotten the point yet, this AI thing is a big deal, and it brings a lot of challenges. And so what we want to talk about today is a path to next generation optics and how we're going to get there. So what I'll do here is kind of set the table with the first few agenda items, which will then get us to the energy efficient interfaces slide. So really what we need to do is identify, what is the problem that we're trying to solve? What are the tools that we have in the toolbox to address that? Do we have the right tools? And then how do we start to execute on that problem solving? So through this process of what tools we have in the toolbox, you'll discover a little bit about some of the work that we do at the OIF. So the OIF, as Vlad said, is celebrating 25 years this year, and we have over 140 members, which are truly a broad cross-section of the industry, from test and measurement to network operators, component providers, equipment developers. So it really is the full industry ecosystem where we can come together and solve problems. On this slide, we show some of the different work groups that we have in the OIF, including the optical co-packaging, the protocol group, management, which you'll see is an important part of this, electrical interfaces, and then, of course, the networking aspects. So again, to identify some of the tools that we have in the OIF to help us with developing these solutions we need for next generation optics is the common electrical I/O track that we have. And this is where we develop the industry standards for electrical interfaces from a chip to a chip, or chip to a module, as the case may be. So here we're looking at the 7 different specifications that we have either finished or are in process of defining for 112 gigabits per second. And what this does is it allows the industry to use the interface that is most cost effective for the link that they're trying to implement. So we're always trying to find a way to set the industry up for these low power or lowest possible power solutions in terms of the electrical interfaces that the industry is going to deliver. In the area of the 100 gig development work, one of the projects that we have going right now is a linear optical project. So linear optics are not new. This is something that the OIF has been working on for a couple of years, and we've learned a lot from this, and one of the things we've learned is it's really hard. It's a hard problem. So in this 112 gig linear project, what we're trying to work with is the optical budget that has been established already in IEEE for 100 gig, and then define an electrical channel that can drive that optical budget in a way that allows us to take the retimers out of the optical modules. So significant cost and power savings, but really a very challenging problem because that optical budget wasn't set up with this in mind. And so how do, the challenges that we face are how do we get to interoperability? So as I mentioned, we've been working on this a couple of years now, and you're now seeing the fruits of that effort through all the discussions that came out at OFC and just a couple of weeks ago at ECOC, where demos are starting to happen. But is it true, are we fully there from the standpoint of a fully interoperable industry standard? Because that's where we're trying to get to, right? If we're going to support this hyperscale industry, then we need to get to that broadly interoperable solution. And it's a challenging problem. So then looking forward, 200 gigabits per second. So that work has started at the OIF. We've got 4 projects going right now. The extra short reach is an electrical interface like you would use for co-package optics, something like that, very short. VSR is a chip to module, and then MR and LR are longer electrical links, like a backplane or a copper cable. The next project area that I want to mention at the OIF is the CMIS, Common Management Interface Specification. And so what this development has enabled the industry to do is put a common communications understanding on all the hosts that are built in the world and into all the modules that are built into the world. And so it takes all that bring up and all that deployment challenge off the table, and it allows the industry to unify around that. The other thing that it does, and I think this is going to be important for us with energy efficient interfaces, is it allows us to have a more intelligent module and have the host take advantage of those intelligent capabilities. And I think we're going to need that as we figure out how to move forward with energy efficient interfaces. So some of the key concepts that we have here is that we define a media lane. We have these EPCEL codes in the module that define how the module is going to be used, and then the host knows how to instruct and configure that. And then the module does advertising. So you plug the module in, it tells the host what it's capable of doing. And the same concepts will also be built into co-package optics implementations as well. A brief word on the coherent activity in the OIF. So this is another development track that we have. And as we move forward each day, we see that we are getting closer and closer to where coherent is going to deliver value inside the building, not just between buildings. And so this is another tool in the toolbox as we think about how to serve the industry moving forward. And so this brings me finally to the co-packaging track. In the co-packaging track, we set out about 2.5 years ago to quickly identify a methodology and an interoperable interface that would enable the industry to start looking at co-packaging. And so we wrote a spec for a 3.2T optical module. We identified an external laser form factor so that we could bring the laser light into that transceiver. And then we have the XSR electrical interface between the host chip and that co-package optics module. And then finally, the last thing that we've started to do in the co-packaging track is work on the energy efficient interfaces, which is what you really want to hear about today. So this is the output from the 3.2T co-packaging project, and there actually is a switch out in the exhibit hall today that implements all of these solutions. So it has the OIF defined LGA socket, it has the copper cables, and it has the optical modules all integrated around a nice Broadcom switch. So I encourage everyone to go and take a look at that. But this is what we really want to talk about today, is the energy efficient interfaces project. So now with all that other awareness of what the OIF is doing in other areas, the industry has come to us and said, we need help with next generation electrical interfaces and optical links. How are we going to do this? We've watched you work on the CEI 112 gig linear project, and we need to think about our next generation. How are we going to do this next? So this is a process that we've used repeatedly in the OIF, and it's a process where we all work together in what we call a framework project, and we write a white paper or a set of requirements. We define what are the different challenges, what are the different constraints, what are the technologies that are possible, and this allows us to then start specific development projects to identify those needs. And so we're in this framework project, a framework portion right now, where we're identifying some of the requirements that the previous speakers have talked about, and then we can prioritize those projects. And we can start those projects as quickly as we reach consensus on what the challenge, the requirements are. And so this process can work very quickly, and it's a process that can really build industry consensus so that we have agreement on what are the requirements we're trying to do. There's a few different configurations that could be considered for this, such as onboard optics, co-package optics, pluggable optics. And so these are all the different physical configurations that we're trying to think about. And then the next question is, where do we establish the boundaries between the electrical interface and the optical, and so that we can have the interoperable standards definitions so that that link will always work. no matter who the supplier is, no matter who the end user is. And so we need to think about, are we trying to totally eliminate retiming? If we totally eliminate retiming, will that give us the reach, and will it give us the link robustness that we need? Or could this be partially retimed? For example, transmit retiming or something like that. Or is it simply how we define the equalization that's applied? So do we put pre-emphasis on the transmit side and we standardize how we do that so that we achieve this interoperability? So a lot of different directions we could go with regard to how we establish the boundaries. So we got the challenge that I just identified of the physical hardware. Is it co-packaged? Is it pluggable? Now we have the challenge of where are we going to establish the boundaries on that? And then the next thing, as the previous speakers have talked about, in these new network architectures, we have our front-end network, we have our back-end network. Wait a minute, what do we mean by the back-end network? Are we talking about just how we're going to network a cluster of GPUs? Or are we talking about, as is shown on the right side, how are we going to interface at maybe it's a PCIe data rate directly onto the GPU? So these are inputs that on the left side of the slide that Meta brought to the OIF. On the right side, these are inputs that Ram brought from Microsoft. And these are all part of the considerations that are now being discussed and debated in terms of, where do we prioritize? This problem is a tremendous scope. And this slide kind of shows the breadth of that scope. So we have the compute side of the network, or backend as we want to call it, and we have compute to I/O, compute to memory, and compute to compute. And what are those requirements? And then there's the GPU cluster to GPU cluster. What are those requirements? And what do we need to do in terms of latency? Those are going to help us figure out where we need to put those boundaries so that we can come up with this standardized interface. So it's a very challenging problem. We have the best minds in the industry, that members of the OIF that are working on it, and we're trying to now lay it out like this in a roadmap so that we can prioritize. That's the one. Let's go do that problem first. Let's figure out how to solve this problem. It's a big deal, and so we're trying to do it in a methodical way, but using a process that has been pretty nimble for us in the past and should enable us to get this framework put together and get the project started. We want to get the project started, but we don't want to do it wrong. So we need to have this consensus building. So call to action. I don't think anyone has been in a presentation over the last 2 days where there hasn't been discussion on the power growth trajectory. So that's identified. We have to do something about that, and that's what we're here for. We're doing that. How do we get the alignment? How do we get the industry? And that's what we're doing through this framework project. We're capturing those inputs. We're sitting around the table working on that. We've established liaison relationships with many organizations around the industry, and now we're adding those liaison relationships in specific areas that will help us identify energy efficient interface opportunities. Then we can start the prioritization, and then we can get to work on the standard. So that's where we need to get to, right? You don't want a bespoke solution at each hyperscale. We want a broad industry standard that has interoperability. So back to you, Vlad. I'm all set.
Thank you, Nathan. Everybody's getting a message that the earthquake detected. Wow, you made a big impression with your speech. I don't feel any earthquake. All right, we will ignore the earthquake. Any questions to the speaker? I know you have a lot of ambitious goals in front of you, but maybe a low-hanging fruit for the industry is those linear drive pluggables, which came as a surprise to all of us about a year ago But it seems like they're making good progress in terms of getting into the fields and suppliers learning how to make them, how to test them. Customers are becoming more receptive. How's progress at OIF on the LPO front?
So as I mentioned, so we are making good progress. So we recently, the draft spec that we have just went through a ballot review cycle. So we've got a new round of member input on that. So with each generation, the document becomes more mature, and we're getting to the point now where things are starting to become actually pretty firm. And as we mentioned, you know, there was all the modules that we saw or the buzz that we saw at OFC, and then only a few months later at ECOC, all the demos that we saw. So now people have real data, you're right. They're bringing the data into the OIF, and so that's becoming part of finalizing that specification. So we are making good progress. I think we chose the right objective by basing it on the Ethernet optics budget, because that's the optics that's available for us to work with. But that brings some of its own challenges. That optical budget wasn't set up with LPO in mind. And so I think we're making good progress. I think we're going to get there. But the way we did it, it creates that little bit of a speed bump. Now, hopefully, looking forward, energy efficient interfaces, we can take a holistic look at the optical budget, the electrical budget, get an industry-wide solution through liaison relationships with other bodies and other forums. So.
Right. Good. Go ahead.
Yeah, you were talking about standards for the external laser source for co-packaged optics, and I was wondering, are you guys working any with standards for the comb laser sources that have been emerging recently?
So no, there hasn't been any work on that in the OIF, and there might be in some other industry bodies that I'm not aware of, but no, we haven't looked at the comb lasers in OIF yet.
Any other questions to the speaker? Well, let us thank Nathan again. Thank you very much.